Today we're going to look at a proof with parallel lines where we're asked to prove that angle 14 is congruent to angle 13, angle 3. And so we're working with congruent angles. And so with all the other proofs that we've done in class, we're going to start with our given. So I'm going to say A is parallel to B, and our reason is that that is given to us. All right, and statement number 2 is that C is parallel to D, and the reason is that is also given. And so now, in order to complete our proof, we're going to look at what it is we're trying to prove, and we're going to do a little bit of pre-planning. And so we see that angle 14 is congruent to angle 3. Well, I'm trying to go from the angle formed by lines B and D over to angle 3 and show that there's a direct relationship. And angle 3 is formed by lines A and line C. So in order to get from angle 14 to angle 3, we need to find some angles in between that they are both congruent to. So one example is I could go from angle 14 to 11, which is alternate interior, and then to 3, which would be corresponding. I could also go from angle 14 to angle 10, which is corresponding, and then 10 and 3 are alternate exterior. I could also go from 14 to 7. Those are alternate exterior angles, and then I could go from 7 to 3, which is corresponding. I could also go from 14 to 6, corresponding angles, and then I could go from angle 6 to angle 3, alternate interior. I could also go 14 to 15, vertical, 15 to 6, alternate interior, 6 to 3, alternate interior. And so one thing I want to point out, the more angles we use, the more steps we're going to have to include in our proof. And so typically we want to try and show the shortest route possible. Additionally, I could also go from 14 to 5, which are alternate exterior, same side exterior, but those angles are supplementary, and so are 5 and 3. While we could go that route, that would just mean more steps because those angles involve angles that add to 180, whereas we're just trying to show a pair of angles are congruent. So I'm actually going to use 11 as my go-between angle. And so I'm going to go from angle 14 to 11. And so my third step is I can say that angle 14 is congruent to angle 11. And we know that those angles are congruent by the alternate interior angle theorem. Additionally, we know that to angle 11 and angle 3 are corresponding angles, and with the lines being parallel, we know that those are also congruent. So my fourth statement is that angle 11 is congruent to angle 3, and that is by the corresponding angle postulate. And so now, going back to the key questions we've always dealt with in terms of proof, is anything the same? And I can see that my statements 3 and 4 both have an angle 11, and I know angle 14 is congruent to 11, but 11 is also congruent to 3. And so because 14 and 3 both are congruent to 11, I can say that angle 14 is congruent to angle 3 using the transitive property, which says if A is congruent to B and B is congruent to C, then A and C must be congruent. And so using 14 and 3 as my third pair of congruent angles. Now, this concludes this proof. Now, there are multiple other routes we could take, as I've highlighted down before. 14 to 10 corresponding, and 10 to 3 alternate exterior. And so our proof would look very similar with our statements. Our reasons would be slightly different, and again, my fifth statement would be a transitive. And again, the more angles you include, yes, 14, 15, 6, and 3, those are all congruent, but the more angles you include, the more steps your proof is going to have.